Yes, please. Can you? Can you see my screen? Firas, are you with me? Yes. Can you hear me, students? Yes, students. Who can read the first question? Firas, Yazid, are you there? Here we have the first question. Water boils at different temperatures based on its elevation above sea level. Rob and Anne are in different cities. They both boil water in a number of pots. Each person records the water temperature just as the water starts to boil. Now, the higher the elevation, the lower the boiling point is, and the lower the elevation, the higher the boiling point is. Now, they use box plots to display their data. Compare the medians of the box plots. What inference can you make based on the median values? Okay, who can answer? Yes, please, students. Firas, are you there? Firas, Yazid, are you there? Okay, I'll solve the first question here. As you can see, here we have 95, 95.2, 95.4, 95.6. I think it is 95.7 here, the boiling point degrees in Celsius, 95.7. And here it is also 95.7. So I think the medians are the same. And which of the following is the best inference based on the median values? The first choice is Anne is at a greater elevation, Rob is at a greater elevation, and Rob and Anne are at the same elevation. The correct choice is C, depending on the median values. So as you can see here, this is the correct answer. Let's take a similar question. Here we have another question. Who can read the question for us is the same. You have to compare uh, the medians of the box plots. As you can see here, we have or the medians are about the same, okay, and that means the Rob and Anne at about the same elevation. Let's take another question here. Medians are the same elevation. Let's take another question. So I hope you concentrate with me, please. Here, the following box plots show different heights of two types of trees. What is the best description of the medians for the box plots? Are you always always able to make a clear inference from the data you are given? Explain here. Which of the following is the best description of the medians? Look here, the median is about 61.2, or it's exactly 61.2. And here it's about 61.3, are about the same, I think. Okay, are about the same. Here we have another question. Students, please participate. Firas, Yazid. The median here, the medians are the same. Let's take a similar question. Okay. Here also the medians are the same. Similar question. The line in the middle represents the median. Okay, here we have different medians. Look here, the median for tree 1 is about 73.5, and here it is about 71.2. So the median of tree 1 is greater. Okay, take another question. Also here we have tree 2 with a greater median. Okay, so as you can see, you can compare using medians. The box plot, the line in the middle of the box represents the median. So students, you have 1 minute to read and answer the next question. Who can read and answer this question, please? Yes, please. Students, Firas, Yazid, are you there? Yes, please. Anyone of you? Anyone can read this? Firas, Yazid, are you there? Yazid, good morning. Yazid, are you there? Yazid, can you hear me? Sammy, good morning. زين. Take absence. Didn't know what happened to Sarah. Now, let's continue. We can read this question. A family is looking for a new home. The family is comparing homes in two towns. The median home price of town one is $200,000. In town two, the median home price is $200,000. Based on the median home prices of each town, what inference can he made? What else might a person conclude from the median values? So here we have the first part of the question. Which of the following is a correct inference based on the median values? Who can answer this question? Take 1 minute. Take 1 minute to answer this question. Yes, please. Are you there, students? Yazid Nawaf Ghamdi. Abdullah Abdelilah. Sorry, Abdelilah. Good morning. Good morning. So I think the answer of this question, the homes in town 1 and town 2 are similarly priced. Okay. Now, which of the following is another conclusion that a person might make from the median values? I think the homes in each town are about the same size. Okay, so take another question. A family is looking for a new home. The family is comparing homes in two towns, and the median home price of town one is $400,000. In town two, the median home price is $460,853 based on the median home prices of each town. What inference can be made, and what else might a person conclude from the median value? So here, which of the following is a correct inference based on the median values? As you can see here, the median home price in town 2 is greater than the median home price in town 1, so we can say the homes in town 2 are more expensive. Okay, and here we have the next part of the question. Which of the following is another conclusion that a person might make from the median values? Depending on the previous part, we can say that the homes in town 2 are probably greater in size because of its price. Okay, so this is about question number 3. Let's see question number 4. The following box plots show monthly average high temperature from January to December in degrees Fahrenheit for two US cities, and which city should you live in if you want the most variability in temperature? As you can see here, we have two box plots, one for city X and the other for city Y, and the width of the box in city X is about 50 minus 20, 30, and in city Y it's 50 minus 25, 25, which means that the width of the box in city X is greater than the width of the box in city Y. So I can say that here, to answer this question, which city should you live in if you want the most variability in temperature? I think it's city X because of the width of the box. Okay, so this is how to answer such questions. If you want to check the variability, you have to concentrate on the width of the box. Let's take a similar question. And also here we have another question, generic question. The following box plots show monthly average high temperature from January to December in degrees Fahrenheit for two US cities. Which city should you live in if you want the most variability in temperature? As you can see here, city Y. I think city Y, because of the width of the box here, is about 45 minus 20 gives you 25, sorry, 25, yes. And here, 50, 20, which means that the width of the box in city X is greater than the width of the box in city Y, which means that in city Y we have more variability in temperature than city X. Okay, let's check here. Paulina compares the high temperatures in city 1 and city 2 for 1 week. In city 1, the range in temperature is 11 degrees Fahrenheit, and the interquartile range is 6 degrees Fahrenheit. In city 2, the range temperature or the range in temperature is 20 degrees Fahrenheit, and the IQR is 6 degrees Fahrenheit. What might you conclude about the weather pattern in each city based on the ranges and interquartile? Here, as you can see, the weather pattern in city 1 is more consistent than the weather pattern in city 2. The weather pattern in city 1 and in city 2 or in city 2 are equally consistent. The weather pattern in city 2 is more consistent than the weather pattern in city 1. The range and then do not provide enough information to make a conclusion. Here, the differences between the ranges and the interquartile range in city 1 is less than. Okay, so we can say the weather pattern in city 1 is more consistent than the weather pattern in city 2. So this is the way you have to check. If you do not understand, you can view an example here. Khatam, good morning. So Pat compares the high temperatures in city 1 and city 2 for 1 week. In city 1, the range in temperature is 24 degrees Fahrenheit, and the interquartile range is 9 degrees Fahrenheit. In city 2, the range in temperature is 15 degrees Fahrenheit, and the interquartile range is 9 degrees Fahrenheit. So what might you conclude about the weather pattern in this is IQR, and the range and measures are measures of spread. We know that. To draw a conclusion, compare the IQR and the range of the high temperatures for city 1 to the IQR and the range of the high temperatures in city 2. So the range for city 1 is 24 degrees Fahrenheit, and the range for city 2 is 15 degrees Fahrenheit. So city 1 has a greater range. As you can see, it's 24. Now, the IQR for city 1 is 9 degrees Fahrenheit, and the IQR for city 2 is 9 degrees Fahrenheit. So the IQR is the same for both cities. And a greater range and a greater IQR means there are a greater variability or less consistency. Notice that city 1 has a greater range in high temperature than city 2, but both cities have the same IQR. Since the high temperatures in city 1 has a greater variability than city 2, the weather pattern in city 2 is more consistent than the weather pattern in city 1. So as you can see here, we have 11 here, we have 20. So as the range in temperature 2 is, in city 2, sorry, is greater than the range in city 1, so we can say that the weather pattern in city 1 is more consistent. Okay, here we have a similar question. Let's check. Well, compares the high temperature in city 1 and city 2 for 1 week. In city 1, the range in temperature is 17 degrees Fahrenheit, and the interquartile range is 7 degrees Fahrenheit. In city 2, the range in temperature is 8 degrees Fahrenheit, and the IQR interquartile range is 7 degrees Fahrenheit. So, what might you conclude about the weather pattern in each city based on the ranges and interquartile ranges? Here we have equal interquartile ranges and we have different ranges. So the variability in city 1 is more. So we can say that the weather pattern in city 2 is more consistent than the weather pattern in city 1. Okay? So I think this is the correct answer. As you can see, the questions are very easy. Okay, students, are you there? If you have any question about any lesson that we finished this quarter, please tell me. يزيد الغامدي, Sami, Nawaf. Let's check here. You are 7-2. Monday. More Gandhi is here. Yes, no. Anas, no. Khatam is here. Rakan, no. Rayyan, no. Sami here. Sultan, no. Abdullah here. Abdurrahman, no. Omar, no. Ras, yes. Fahad Abdul Jabbar, no. Faisal, no. Nadim, no. Hisham, no. Nothing. Yazid is here. Okay. So let's go and see if we have some more questions from lesson quiz. Survey of seventh um, and eighth grade students was conducted to find out how many hours are spent doing homework each night of the two sets of data which has the greater median. As you can see here, as I told you, the line in the middle of the box represents the median. So the median for the eighth graders is greater than the median of the seventh graders. So it's for here, it's about 4, and for seventh graders, the median is about 3.5. So we can see this is the correct answer. Here we have another question. A random survey of seventh and eighth grade students was conducted to find out how many hours they are spent doing the homework each night. Which of the following conclusions may be made by comparing the interquartile ranges of each set? Um, different conclusions can be made. Okay, the interquartile range for both sets equal. Yes, I think equal to 1 hour because it's from 3.5 to 4.5, so it's 1 hour, and here from 3 to 4 it's 1 hour. So I think yes, we can conclude that. And then the quarter range for it is greater than that, no. Rather for 7, no. The data set exhibits similar variability elsewhere, yes, because of the quarter ranges and ranges also. And the data soon are more skewed, no. So I think we have to inferences. Let's check here. Use the box plot who spend more time in outdoor activity. Here, if you take the median as a measure to compare between the two sets of players, so we can say soccer game players because of the higher greater range, no, because of they are, I don't know, because they are a greater, yes. Okay, so this is on the third question. Let's see the fourth question here. What can you infer about the athletic from the text? So here we have the median tells us that spend more time outdoors over the data set of soccer players shows that they have an equal amount of variability, as you can see. Um, Variability, yes, equal amount of variability. Okay. Let's check here. How can data displays be used to compare between datasets? Data displays be used to compare. They quickly retain measures. Yes. They identify the other ones. No. They show trends in data that can be compared. They display measures of variability. And okay. So let's check. We have a question. Here's some question to check. They quickly illustrate measures of center. Yes, they identify all. Yeah, I think this is the correct also. By the way, you have the answers. Yes, we can check the answers if you want. It's already sent to you. Quickly assessing the variability and other trends that may compare. Okay, so we will check that later. Okay, let's check it now. Why? Mm, it's added already. We have integrators similar. Yeah, see, I think equal amount more. Okay, why is that? You answered that correct. Okay, our period is finished now. This video lecture is already recorded. It will upload it to your Coursera account. You can see it again if you want. Please, if you have any question, please tell me. I will answer it. Thank you for all of you. See you. Assalamu alaikum.